Today we're going to be studying special polynomials called the difference of squares and perfect squares. First, let's look at the difference of squares. The difference of squares are two identical binomials, with the exception that one of the terms is the opposite of the other times each other. Example, a plus b times a minus b equals a squared minus b squared. Well, that's interesting because a binomial times a binomial is a trinomial. That is true 96% of the time. But this is one of the times that it is not true. The difference of squares. Normally, when you have a binomial times a binomial, you should be looking for a trinomial because most students forget that term in the middle. It should have three terms. But this is one exception to that rule. And let's look at this, where we have x plus 5 times x minus 5. And this is how the difference of squares works. We're going to multiply x times x, and we're going to multiply 5 times negative 5. And that is the answer, x squared minus 25. And that only works when I have x, 5, 5. Now it could be a. It could really be anything. But these first two are the same. The second two terms are the same. And one has a positive and one has a negative. And that will give you the difference of squares. Now, what happened to that middle nomial? Well, let's multiply this out and see. Okay, we have the same two binomials as above, and we're going to multiply them out in rows like I like to do. And where do we start? We start at the bottom on the right-hand side. And so we're going to start with negative 5, and let's multiply the entire first row. And that gives us negative x5 minus 25, and then let's multiply out this x times the upper row. There you go. Let's add those together. And there we go. We have x squared minus 25. And those middle terms canceled each other out. We have negative 5x and positive 5x, and add those together and we get a 0. So we end up with a binomial. And it's the only situation you'll have where you'll have a binomial times a binomial equals a binomial. And there are good reasons to use this for more complicated math, which we're not going to get into, but it's very important for you to know how the difference of squares works. Plus, rather than do all this work here, I just did all this to show you that this is true. But all you needed to do was multiply x times x squared, 5 times negative 5, negative 25. Done. Okay? Now let's try another problem. Okay, now this looks a little bit more complicated, but it's really not. It's a little more complicated, but not a lot. It looks worse than it is. But this is the difference of squares again. We have two terms. We have 2x and 2x. Now that's just one term, right? 2x is one term. Remember, look up the definition of terms if you're unsure. It's not 2 plus x, it's 2 times x, and that's one term. So this term is the same as this term, and this term is the same as that term, and both of them are separated by a plus sign and a minus sign. So the middle nomial is going to cancel out, and let's just multiply 2x times 2x and 6y times 6y and put a negative sign between them. That will always be a negative sign. It will not be a plus sign sometimes. It will always be a negative sign, or we do not have the difference of squares. And if they asked you to identify, or if you're on a test, the SAT or something, and you're asked to identify, is this the difference of squares? Well, look, is this a square? Well, 4 is a square. X squared is a square, so this is a square. 36 is a square, right? 6 times 6. Y squared is a square. So this term is a square. We have a square and a square separated by a negative sign. This is the difference of squares. Okay, let's look at perfect square binomials. A perfect square binomial is a binomial times itself. Example, x plus 5 times x plus 5, or x plus 5 squared. So this is a perfect square binomial, and it's a very simple one. And you already know how to multiply it out, so I'm not going to show you how to multiply it out. I'm going to show you a shortcut. Let's multiply a times a, and let's multiply b times b. So we multiplied the two like terms times themselves. Let's multiply the different terms times each other. A times b is ab, and let's just double that. And that's your answer. And if you want to know why we doubled that middle term, what did we do? We multiplied a times b, ab, and then we're going to multiply a times b, ab. ab plus ab is 2ab, and that's why that works that way. Now you can do FOIL, you can multiply it out in rows like I usually do, or you can just take the shortcut, which is the squares are always going to be this way. So let's try another square. Okay, I didn't write out x minus 5 times x minus 5. I did write out x minus 5 squared. I don't need to write it out. If you do, please do so. But I'm just going to do x times x and negative 5 times negative 5. That's right, positive 25. I hope you put positive 25. You didn't put negative 25, did you? Come on. Tell the truth. Anyways, 5 or negative 5 times x is negative 5x, and don't forget to double that. That's right, and that's your answer. And just know something. With a square, a perfect square binomial, this is going to be positive and positive, or negative and positive. This is always going to be positive. Why? Because positive times positive is positive, and negative times negative is positive. But this ends up being a positive times a negative times 2. So if this is negative, then the second term is going to be negative. If the second term is positive, it's going to be positive. But this number here is always going to be positive. Let's try one more perfect square. Okay, this shouldn't take too long, and I shouldn't need to do too much explaining here. 3x times 3x is 9x squared, and negative 7y times negative 7y is positive 49y squared, and 3x times negative 7y is negative 21xy, and don't forget to double it. There you go, and that's your answer. And by the way, when you multiply a perfect square binomial, you end up with a perfect square trinomial. A perfect square trinomial is a trinomial that can be factored into a perfect square binomial. Example, x squared plus 10x plus 25 equals x plus 5 squared. So that square works both ways, coming and going. And you need to do a lot of homework so that you can get this down. I think once you do enough of this with homework, you're going to see that it just seems like they're asking the same question over and over again. It seems really strange at first, or maybe it just seems new at first. But after you do several of these, it just ends up being the same question. And I think you're going to really enjoy your homework.